Hello, I am Sujoy and today I will talk about integration versus differentiation in real life. So today I will tell you about differentiation with respect to integration, how to find out derivative of a function using a graphical calculator and a normal scientific calculator. Next, I will talk about how to find out derivative without using a calculator manually. Everything with a real life integration and differentiation problem. So let's start. So this is our question. F of x or function of x equals to 10x minus x square. Find derivative at x equals to 1. Let's proceed to solution. First, some concepts. You may heard about the term differentiation and derivative. So what is the difference? Differentiation is the process of finding the derivative, and derivative is the slope of a tangent line at a given point. Derivative is also a factor of steepness. Let's go to that. So what is slope? Slope is rise over run. That is small change in elevation divided by small change in horizontal distance. Let's take an example. Let's say this is a hill and you are bicycling on a hill. So by pedaling you are going upward. Let's say your horizontal distance covered is 100 meter and your vertical distance covered or your climb was 50 meter. So your slope of the hill equals to 50, that is change in elevation, divided by 100, that is change in horizontal distance, equals to 0.5. Let's take another example. For another hill, you are going upward. Your horizontal distance covered equals to 100 meter, remains the same, but your vertical distance covered, that is your climb, equals to 75 meter. So slope of second hill equals to 75 by 100 equals to 0.75. So you can see 0.75 is greater than 0.5. So the slope of second hill is greater compared to slope of first hill. That is, derivative is a factor of steepness. So derivative is about finding the slope of any particular point for a graph. I will come to that later. Next, some slope values. When slope equals to 0, there is no angle. This is horizontal line, like cycling on a straight road. When slope equals to 1, that is vertical distance divided by horizontal distance equals to 1. That means vertical and horizontal distances are same. It seems like firing a rocket straight upward. And next, when slope is positive, you are going upward. Again here slope is positive, so the hill is upward. And when slope is negative, you are going downward. That is, you are falling. Next, finding slope of a graph at a particular point. So let's say this is a graph. This is the x-axis or horizontal axis. This is the y-axis or vertical axis. Let's say we want to find out slope at this particular point. So to find slope at this particular point A, we have to take reference of another point called B or some other point. So when B minus A equals to very small, that is the points are very closer to each other, then the slope becomes very accurate because our reference is very closer to our original point. And when A equals to B, that is both the point merges, then the slope is the tangent. That means at this particular point, if you draw a straight line just touching that point on the graph, is called tangent. Like to find slope at this point, we'll draw a straight line just touching only at this point. The slope of that tangent line, that is the climb of that tangent line upward or downward, is called slope of that point. It's also called derivative at that particular point. So here derivative is represented as dy by dx, where d stands for delta or small change in y value divided by delta x, that is small change in x value. So dy by dx equals to slope of the tangent line for particular point of x. It is also called rate of change of y with respect to x. I will explain this later with a real world problem. Now our original function or f of x equal to 10x minus x square given in the question. So f of x equals to y, f of x is also called y, equals to 10x minus x square. Remember, our original function gives us the value of y for any given value of x. Let's say we want to find out value of y for x equals to 2. So we will put x equals to 2 here. We will get 10 into 2, 20 minus 2 square, that is 20 minus 4, 16. So for x equals to 2, y is 16. Next, f dash x or f prime x equals to dy by dx. It's called derivative function of our original function, equals to 10 minus 2x. It is very simple. We know while differentiating, the variable part goes out. So 10 into x, where x the variable, will go out, 10 remains, minus x to the power n or x to the power 2. So the formula for differentiation is n will come forward, 2 will come forward, and x's power will be subtracted by 1. So x to the power 2 minus 1 is x to the power 1 or x. So it will be minus 2x. And this differentiation function gives us rate of change of y at x. Let's say rate of change of y for x equals to 2 will be 10 minus, putting x equals to 2, 2 into 2, that is 6. So at x equals to 2, rate of change of y equals to 6. I will explain this later. Both f of x and f prime x or f dash x are functions. So derivative of a function is itself a function. F of x is 10x minus x square and f dash x is 10 minus 2x. Let's find out derivative of 10x minus x square at x equals to 1. This is our given question. Let's find that out using this calculator. For that, press shift and this integration button. Enter the function 10, press alpha and this button for x, minus alpha, this button for x and this button for square. Scroll to right, enter 1, press equals to. So derivative of the function 10x minus x square at x equals to 1 is 8. So rate of change of y is 8. So change can be either increment or decrement. Let's calculate for increment. F of x equals to 10x minus x square. So by putting x equals to 1 in our original function, you will get 9. Let's increase the x by 0.1. X equals to 1.1, f of x will become 9.79. So change of x is 0.1 and change in y is 0.79. So rate of change equals to 0.79 by 0.1 equals to 7.9, which is closer to our obtained value 8. Again check for decrement also. This is our function. When x equals to 1, f of x is 9. When x decreased by 0.1, that is 0.9, f of x becomes 8.19. So change in x equals to 0.1, change in y is previous value minus new value is 0.81. So rate of change is 0.81 divided by 0.1 equals to 8.1, again which is closer to our original value 8. So average rate of change is 7.9 for increment plus 8.1 for decrement by 2 equals to 8. So rate of change of y is 8 when x equals to 1. Now before I show you the real world problem, let me tell you how to find derivative of a function on Casio fx-9860gII graphical calculator. So this is the graph for our function 10x minus x square, and the shaded region gives us the area under the curve. So to find derivative, press menu 1 for run and mathematics mode, then press option F4 for calc, F2 for divide dx, enter the function 10, press alpha, this plus button for x, minus alpha, plus button for x again, this button for square. Scroll right, enter x equals to 1 and press execute button. So derivative of the function 10s minus x square at x equals to 1 is 8. Now let's move to the question. Speed of a car is measured for a time duration with fixed time interval given in the following table. Calculate the total distance covered by the car during that time duration. You can see speed of the car is measured every 1 minute starting from the 1th minute to the 10th minute, and accordingly speed for each minute is given. So this was the question from my previous video, application of integration in real life. There I find out the distance covered by the car. So I solved that problem using trapezoidal rule. This was the distance. I also solved the same problem manually without using the integration technique, and the distance was 2.75 km. Now let's look at the graphical representation. You can find out this graph in two ways. First, by graphing the original function 10s minus x square, we will get a graph like this one, or if we plot the individual points, that is when x equals to 1, y is 9, for x equals to 2, y is 16, and so on. If you plot the individual points and then if you join the points using a curved line, you will get this graph. This is the x-axis, this is the y-axis. So when x equals to 1, y at this point is 9. When x equals to 2, y at this point is 16, and so on. Now if you look at the data, from x equals to 1 to 4, speed of car or y is increasing from 9 to 24. At x equals to 5, speed is constant. Again from x equals to 6 to 10, speed of the car is decreasing from 24 to 0. Ultimately the car stopped. Let's look at the graph again. From x equals to 1 to 4, the curve is going upward. At x equals to 5, the curve is still, there is no upward or downward changes. And from x equals to 6, the curve started to go downward, and ultimately it touched the x-axis, that is became 0 at x equals to 10. So this is the representation. Now let's check if this statement is justified using the differentiation. For that, press shift, differentiation 10 x minus x square at x equals to 1. So the slope at x equals to 1 is 8. That means at this point, if you draw a straight line just touching only the graph, the slope of that tangent line will be very steep, that is, it is just like vertical. Again, when x equals to 4, the slope decreases to 2. You can see here at x equals to 4, if you draw a tangent line, it will be like this, not like that. That means it is not that steep at x equals to 4. So the steepness of the climb on the hill decreases at x equals to 4. So as I mentioned earlier, derivative at any point represents the steepness of the climb. Again, derivative gives us the rate of change of y with respect to x. Now for x equals to 5, the slope is 0. That means there is not any upward or downward movement. The point is constant. By putting x equals to 6, you can see the slope increases by 2 units but with a negative sign. That indicates the slope is negative and the change is in downward. You are going downward. The positive slope represents upward movement, negative slope represents the downward movement. Let's put x equals to 9. The slope value increases to 8 but with negative sign. That means we are going downward. Slope increases but at the downward trend. That is the meaning of the differentiation. It gives us the slope of a tangent line at any particular point. If you draw a tangent line at x equals to 9, again it will be high, going means the angle is high but direction is downward. That is the negative sign. Now to find out derivative of original function at any value, what you can do manually, first you take the original function, find out the differentiated function. This is original, this is differentiated function. Now put x equals to the x value in the differentiated function to get the derivative. So derivative at x equals to 1 is 8. You put x equals to 1 here, you will get 10 minus 2 into 1, that is 8 is our required derivative. So that is the manual process. So I hope I was able to clear the concept to you. How was the video? Let me know in the comments below. If you like the video, please like and share the video. That will really encourage me. So thanks for watching. See you in my next video. And still then, stay connected by subscribing.